Hello everyone, I'm Anju from the Department of Renewable Energy. So in this session, we are going to deal with the thin film synthesis method. In particularly, we are going to discuss about the PVD method or physical vapor deposition method. So we'll start by definition of a thin film. A thin film is a liquid or solid with one of its linear dimensions being very small in comparison with other two dimensions. Basically, we can define a thin film as any film whose thickness is less than 1 micrometer. So the applications of thin film is very wide. It is almost used in all of the industries, starting from the medical industries, or they are also used in the devices like solar cells. So it has a very wide applications in our day-to-day life. So now we will start with the PVD method. The first is the vacuum evaporation method. That means this is one of the oldest techniques used for depositing thin films. So we will see what a vacuum evaporation method is by looking into the figure. So there you can see a vacuum chamber. So we are doing this experiment inside the vacuum chamber so that our thin film is not contaminated by any other substances from the outside. So there we have a substrate. Substrate means that is the basic layer above which we are coating our thin film. Then we have a substrate holder to hold our substrate. Then finally, at the bottom of the vacuum chamber, we have a crucible. Crucible is nothing but a container on which we are placing our metal or metal alloys that need to be coated. So if you want to coat a silicon thin film, then we will take silicon metal inside this crucible. So crucible is nothing but a uh, container which hold the metal or metal alloys to be coated above the substrate. So vacuum evaporation is still widely used in the laboratory and in industry for depositing metal and metal alloys. So there are three basic steps which take place in the vacuum evaporation method. Let us see what are they. The first one is the vapor is generated by heating. So we are heating the crucible, and when the crucible is heated, the metal placed inside the crucible also get heated and it will melt and it will evaporate. Then the vapor is transported from the source to the substrate. So the evaporated metal is transported to the substrate. Why? Because we have to coat a thin film above the substrate. Substrate is a basic layer above which we are coating our thin film. So it has to be, the vapor has to be transported from the source to the substrate. So where will this vapor go? This vapor will always go from a region of high temperature to cold temperature. So the substrate is the position of the substrate is at a colder region. So the evaporated material will go towards the substrate. And finally, the vapor is condensed to a solid film on the substrate surface. The evaporated material from the crucible is transported towards substrate and it start to layer up above the substrate. So layer by layer they are getting deposited above the substrate and they will form a thin film. So this process is called the condensation. So basically there are three steps in the vacuum deposition method. First one is vapor is generated by heating. Second one is vapor is transported, and finally the vapor is condensed above the substrate. So we know the first step is heating the crucible. So there are different methods employed for heating the crucible. The first one is resistive heating. Heating the material with a resistively heated filament generally made of refractory metals. So what is refractory metals? Molybdenum, tungsten, all are examples for a refractory metal. So what is a refractory metal? Those metal which can sustain high temperature, because we are heating by using a filament, so that the filament should not melt itself, and then if the filament is melting, the material from the filament will evaporate and will contaminate the thin film, because those filament is going to get deposited above the substrate. So we are going to choose a filament which is made up of a refractory metal so that they will not melt. What are the examples for refractory metals? Molybdenum, tungsten. So all other processes are taking place. The three steps are taking place. We are heating with the refractory filament here, and then the metal placed inside the crucible get melt, evaporated. Those evaporate materials are transported to the substrate and finally they are coated above the substrate. So next we are going to discuss about the electron beam evaporation. This was first used by Pratt and Whitney, and the source itself is an electron beam gun. So here we are taking electron beam gun and heating the source itself. Crucible is not heated here. We are directing the electron gun magnetically towards the metal. So what is the benefit of using that here? The crucible is not heated. So that is a benefit because there is a chance that the crucible itself get melted and contaminate a thin film. So here, since we are using electron beam to heat the metal itself instead of the crucible, this is not going to pollute the thin film. So this is one of the benefit of using electron beam evaporation. Electron beam are used to locally heat the source. The next method is RF induction. What is RF induction? We are using high intensity electron beam gun here. Beam is magnetically directed onto the evaporant and film is not contaminated by the crucible. But the disadvantage of this is that it is very costly equipment. And what is the advantages? The advantage is that it is not going to contaminate the thin film because crucible is not going to melt because we are directly giving heat to the metal. So this is the RF induction setup for depositing thin film. Then we have flash evaporation method. So this is the experimental setup for flash evaporation method. The processes are same, but the method is little bit different. Let us see. Fine wire or source material is fed continuously onto the hot ceramic pan. The film composition is accomplished by evaporating small quantity of components in the desired ratio. So here we can see we are taking the metal to be coated in a powder form here and we are continuously feeding that into this hot crucible. So the remaining steps will take place as usual like in the vacuum evaporation method, but the heating is different here. The next method is laser evaporation method. So we know laser have different application. Laser have application here also to coat a thin film above the substrate. How? NMS intensity of the laser is used for evaporating. Laser is kept outside the vacuum chamber. We know we are doing this thin film coating by vacuum evaporation method. So vacuum chamber is involved here, but we are keeping this laser outside the vacuum chamber, and then we are focusing our laser beam towards a target material. Since this laser do not penetrate deeply into the target material, the surface is only the vacuum is focused on the material surface and the evaporation is taking place only at the surface. Why? Because the laser do not have capacity to penetrate deep into the target material. So by the method of laser, we are evaporating the target material at the surface and the metal evaporate and finally condensate onto the substrate. So these were some of the method by which we can coat a thin film over a substrate. Thank you.